All right, we're at question 22, and this is the last question in the passage, so it will tend to be a little trickier than the other ones since they get harder as the passage goes on. And it says, based on table 1, so that'll be the first thing we have to find, 2 milliliters of heptane, that'll be the second thing, were mixed with 8 milliliters of isooctane. The octane number of this mixture would be, so we need to find the octane number. Now, one of the things I want you to remember, the last question, right? The last question of the passage. If it seems very straightforward, you probably want to look at it again, because most of the time it's not. If it just is, it's like, oh, I just have to read a graph and pull this number off and I'm done. Chances are they've snuck something in there to make it a little trickier. And this is a prime example. Because look at this, table 1, right? So it says 2 milliliters of heptane. So we've got 2 milliliters of heptane and 8 milliliters of isooctane. And this is where doing a lot of questions and just getting experience really makes all the difference in the world. And if you're trying to get that 35, 36, experience just really helps you. Experience with official ACT questions like these really help you get to that level, because you start to see how the ACT tries to trick students that are not paying attention. So anyway, that's what we have. So I'm going to show you how I think a lot of students would approach this to get the wrong answer. They would say 2 milliliters of heptane. Okay, here's heptane here, and it's between 0 and it's 0. Heptane basically doesn't affect the octane number at all, right? If you look at it here, the volume of isooctane at 100, it's 100. At 90, it's 90. At 75, it's 75. At 50, it's 50. At 10, it's 10. At 0, it's 0. What heptane is doing, it doesn't matter a fig. It's basically isooctane is dictating the octane number. So they've gone, okay, so what the average student's going to do is say, hey, volume of isooctane between 0 and 10, so it's here, right? And it's 0 and 10, so it must be 8. Oh, Yahoo, look, it's right there at G. I found the right answer. That was easier than I thought. And move on. And they would be wrong. And I think probably the vast majority of students that tried this would get it wrong, because it's the last question and it's never going to be that straightforward. And what they're expecting you to look at is all of these volumes, right? Why heptane's there is to get the volume to 100. 100, 0 plus 100, 10 plus 90, 25 plus 75, 50 plus 50, 90 plus 10, 100 plus. So if you've only got 8 milliliters, you've got to pretty much multiply that by 10 to be able to read off of this graph. You can't just stick 8 milliliters of isooctane into this. So if it's 2 and 8, that gives you 10 milliliters. This table is dealing with a total of 100 milliliters. So whatever the answer is that you get, you have to multiply it by 10 because you've only got 10 milliliters. So if you got the answer 8, you would multiply that by 10 to get the answer, and it would be 80 milliliters. And if we could come over here, we see that's answer J. So that, and again, the more you do these questions or watch these videos and let me do them, you start to see how they trick you, and you get to get a sense of, wait a minute, this is the last question. It shouldn't be that easy. What have I missed? And that is so typical of the ACT, of how they would throw that in. They, they would try and get a student who just sort of says, oh, 8 milliliters, it's only going to be 8, and then just not see that this table is dealing with 100 milliliters, and that you would have to multiply the answer by 10. So anyway, that's how you get J. That's a little bit of a trick question, but hopefully, again, the more you do these questions, the more you'll see the tricks that the ACT throws at you, and you will not fall for them, and it will improve your score quite a bit.